Today we are going to look at lesson 6.6, and I don't have my fancy note sheet for you today. We're going to have to go old school with Mrs. Fleming's drawings. So today we're going to talk about applications of trig into contexts. So the first thing we need to talk about is angles of elevation and angles of depression. So here's my fancy person because I am an expert drawer, as you can tell. So here's my person. A person's eye level would, if they just have their head straight, their natural line of sight would be right at their height and it would continue out forever and ever. But if they move their head up or down, then they create an angle of elevation or an angle of depression. So I have a balloon up here in the sky. So let's say our person here wants to look up at that balloon. We'll go right at the middle of the balloon. So now their angle that their eye is looking is now here. And this angle that is created right here is the angle of elevation. So elevation is when you are looking up in any way, shape, or form. So that would be our angle of elevation. So if we were to ask, like, how high in the air is this balloon, if we knew the angle of elevation and if we knew this distance here of how far the person was from directly underneath the balloon, then using trig we should be able to find this height right here. We'll do some practice questions like that here in just a minute. Alright, so that's angle of elevation. Let me color that one in so I'll be able to differentiate it from my other angle here in just a moment. Okay, so if we look up, we create an angle of elevation. Now our other vocab term is angle of depression. So now I have this nice little turtle on the ground down here. So let's say our person wants to look down at that turtle, then now they have looked downward at something, but they've still created an angle. The natural line of sight, remember, was straight out this way, and now we have looked down, so now we have this dashed line. So the angle that's made right here between the natural line of sight and this downward look, this would be an angle of depression. So when we look down at something, we're looking at an angle of depression. There's not a lot of natural context for angle of depression other than looking down at the ground for something, but like if you're up in an airplane and the pilot sees something on the ground, or if you're riding and you have a window seat and you see something down in the ground, then that would be an angle of depression. Or let's say like you're on the top of a building filming the Macy's Day Parade as it goes through, then you would need to set an angle of depression on your camera so that you could film the floats as they go by on the ground. Those types of things. Your angles of elevation typically are something where you start on the ground and are looking up at something in the sky. Looking up at the top of a tree, looking up at a bird, looking up at the top of the St. Louis Arch, things like that. So in just a second, I'm going to switch papers and we'll take a look at some examples, but you can't laugh at my computer-aided drawings. Alright, so this paper is actually normally the last page of one of the homework assignments, but I decided, hey, we're not doing this page as homework assignment, let's just use it as notes. You guys are just going to have a few, I think like 5 application questions. So when you read through the application question, you want to sketch a drawing of it and create that into a triangle, of course, and label everything that you know. So at a point on the ground 50 feet from the foot of a tree, so foot of a tree would be down at the bottom, so 50 feet from a point to the tree, and the angle of elevation, so that means from the ground up to the top of the tree, from the ground to the top of the tree is 53 degrees. And we want to know the height of the tree. So from this tree to the ground, that's our x. So now we're going to use trig to set that up. So here's our angle of focus. This 50 feet is the leg that is touching, so that would be the adjacent. And this x is over here on the leg that is not touching, because here would be our 90-degree angle. So this is our opposite. The hypotenuse would be this line right here. It has no mark on it, so we're not really concerned about that one. So which trig uses adjacent and opposite? So in case you forgotten since yesterday. Let's look at SOHCAHTOA. Remember, the first letter is the trig statement, and then the other two are the letters that we need. So we need A and O, so that appears here. So we're going to want the tangent, and then we put our angle measure, so 53 degrees is equal to opposite over adjacent, so x over 50. Now we're going to take that equation and solve it. Remember, our goal is to get x alone, so we need to get rid of this time, or dividing by 50, so we're going to times by 50, and what we do to one side we do to the other. So 50 times the tangent of 53 will be our value of x, and that's what we'll type into our calculator as we work. So let's see, 50 times the tangent of 53, and we get 66.35, so we're going to round that to 66.4 as the approximate value of x. Now these are word contexts, so they're going to require a word answer. The question was, find the height of the tree. So the tree is, and we can say about or approximately, whatever word you want to use. I don't know if that has an E in it or not, but we'll go with it. 66.4 feet was our label. Tall. Make sure your answer answers directly what the question was. All right, moving on to the next computer enhanced drawing. The top of a lighthouse, can't you tell that's a lighthouse, is 210 feet high. The angle of depression, so we're looking down at the boat. And remember, natural line of sight is flat, parallel to the ground. So this angle is 27 degrees. And what we want to find is the distance from the boat to the foot of the lighthouse. So this is what we're looking for. Now, here's where it gets a little bit tricky with angles of depression. That 27 degrees isn't even in the triangle. The triangle is down here. So I need this angle, which is the partner angle, to the 27. So if this is a right angle or 90 degrees down here, then together these two would make a 90 degree or a right angle. So we can grab our calculator and do 90 minus 27, and we get 63. So this angle inside of the triangle is 63 degrees. That one will need to be our angle of focus because it's in the right triangle. Now we can set it up. The 210 degrees is adjacent, and the x is on the opposite. This one over here is the hypotenuse, so we don't have any information on it. So adjacent and opposite, that's a lot like last one, so we'll be using tangent. So the tangent of 63 degrees, remember we want to use the angle that's in the triangle, is equal to opposite over adjacent. So x over 210. To get x alone, we'll need to multiply by that 210. What we do to one side, we do to the other. So 210 times the tangent of 63 degrees should give us our value of x. So that's what we're going to type into our calculator. 210 times the tangent of 63, and we get 412.14. So we want to keep 412.1, and it's not going to round up. So 412.1 is approximately x. So it asks, find the distance from the boat to the foot of the lighthouse. So the distance from the boat, and I'm just using the question to guide my answer, to the foot of the lighthouse is about, and we could probably even round that to just 412 since it's just slightly over. So 412, what's our label here? Feet. All right, So the angle of depression, like I said, that's just tricky because you have to use the angle that's actually in the triangle. Sometimes the angle of depression will be, but most of the time it's not, and you have to end up doing 90 minus your angle of depression to get the angle that's actually inside of the triangle. All right, Richard is flying a kite. The kite has a string that is an angle of elevation of 57 degrees. Now, here, there's the base of the string, and it's going to come down and make our 90 degrees here. So the angle of elevation is not actually from the ground, it's from the point where he's holding it, and that is 57 degrees. If Richard is standing 100 feet away from the point on the ground directly below the kite, so 100 feet right here, how much string? Find the length of the kite's string. So this is what we're looking for, which is actually going to be our hypotenuse. So here's our angle of focus. The 100 feet is a leg that's touching that angle, so that would be adjacent. And the x is on our hypotenuse this time. So which trig uses adjacent and hypotenuse? And we can slide back up to look at our abbreviation, adjacent hypotenuse, so we want the cosine. So our equation needs to be the cosine of 57 degrees is equal to adjacent over hypotenuse. Now x is in the bottom, so this is where we get to use that shortcut of flipping the x in the trig statement around. So x equals 100 over the cosine of 57 degrees. That's what we'll type in our calculator and see what we get. So 100 divided by the cosine of 57, and I get 183.60, so 183.6. But we have to be careful, because if this had asked anything about the height that this was up in the air or something like that, then we would have to incorporate in the distance from the ground to where we made our triangle. So luckily this one just asks for the kite string, so we don't have to worry about Richard's height holding that. So now we can just answer our question that we have the kite string is about 183.6 feet long. All right. Now we have this car and a tower, so the angle of elevation from the car to the tower, so elevation, and I'm going to go all the way to the ground here because it doesn't tell me to do otherwise, is 32 degrees. The tower is 150 feet tall. How far is the car from the tower? So here's what we're looking for. Here's our angle of focus, and this is our adjacent, since it touches the angle but is not the hypotenuse. This one would be our hypotenuse because here's our right angle. And this one would be opposite, so we're once again looking at tangent since we have opposite and adjacent. So tangent of 32 degrees equals opposite over adjacent, so 150 over x. X is in the denominator, so we'll be able to use that shortcut where we flip the x and the trig statement around. So we will have x equals 150 over the tangent of 32 degrees, and that's what we'll type into our calculator. So 150 divided by the tangent of 32 equals, and let's see, we get 240.05. So we're probably just going to use 240, and we'll say x is approximately 240. And answer, how far is the car from the tower? The car is about 240, what's our label, feet from the tower. Okay, now you're probably thinking, I got it, Mrs. Fleming, we don't need another one, but I do want to do this last one because it is a little tricky and a little bit different. A ladder on a fire truck. Don't you like my fancy computer-aided fire truck here? Nice wheels, the main part of the fire truck. I'm not really sure what I wanted that to be, but whatever. The ladder of a fire truck is 8 feet from the base of the ground. So you know how on a fire truck the ladder doesn't come off the ground, the ladder comes off the truck. So it's telling us this distance from the ground to the top of the fire truck where the ladder is 8 feet. The maximum length of the ladder is 100 feet. So the length of the ladder can go up to 100 feet. And the ladder's greatest angle of elevation, so where the ladder meets the truck, this angle right here, that greatest angle is 70 degrees. What is the highest above the ground that it can reach? So here's our 90-degree angle, and this is what we need to know. How high above the ground can that reach onto the building? So we have our 70 degrees. The 100 is our hypotenuse. And this is the adjacent because it touches, so x is on the opposite. So which trig uses hypotenuse and opposite? That would be sine. So we have the sine of 70 degrees is equal to opposite over hypotenuse, so x over 100. Right, opposite over hypotenuse, so x over 100. We want to get the x alone, so we're going to multiply by 100. What we do to one side, we do to the other. And so we'll be typing in 100 times the sine of 70 degrees to give us the value of x. So we'll type that into our calculator, 100 times the sine of 70 degrees. And we get 93.96. Okay, so this 6 would cause that to go up, which would cause the ones digit to go up. So we're looking at 94.0. It is still not equal to, that's still approximate because we did do some rounding. Okay, now here's where we get tricky. That 94 is the distance from the top of the truck to the top of the ladder. This is what we were trying to find with that x. But there's more distance to the ground. So it's not just the 94 feet that occur right here. We also have this distance to the ground. This distance to the ground, we said at the very beginning, was 8 feet. So we have to add in the 8 feet right there, and then we will be able to give the distance that it is all the way to the ground. So we get 102.0 is approximately the overall height. It's not just x, because x really was just the top of the ladder up to here. So what's the highest above the ground that it can reach? It can reach 102 feet above the ground. Of course, we would write that out in sentence form. So be careful today as you're going through your questions. There's going to be some pictures on there. You'll want to have scratch paper. You'll want to write out your triangles and label everything that you can. Write your trig equation and then solve that. And then don't forget to give your answer in sentence form since it is a word problem. Let me know if you have any questions. Don't hesitate to shoot me an email or give me a call. And I don't mind at all if you just take a snip of what it is you're working on and shoot that to me and say, is this right? Am I on the right track? Or what did I do wrong? I'm happy to help. Remember, that's what I'm here for.